Hey, we're going to solve systems of three linear equations. And I'm assuming that you already know how to solve a system of two linear equations. That's going to come in handy because the first thing we're going to do is eliminate one variable from two different equations so that we can get a system of two equations with two variables and solve it first. So let's do our first example. So our first equation in this system is 3x plus 7y minus 15z equals negative 12. Then we have x plus 2y minus 4z equals negative 3. And our third equation is negative 4x minus 6y plus 15z equals 16. And because we're going to be doing a lot of work on this, it's very important that we use appropriate labels and show our work neatly so we can keep track of where we're at. So I'm going to call each equation a row. So I'll call this row 1, and then row 2, and row 3. And as we get subsequent equations we'll use, we might call them row 4, row 5, etc. The reason I'm doing that is because this is going to lead into using matrices to solve systems, and this is a common notation for matrices. All right, so what do we want to do first? Well, we need to decide on a variable to eliminate so I can get two equations in terms of the other two variables. And so I see in row 2 I've got this x, which is just one x. That means I can use it easily to eliminate the 3 in row 1, and I can easily use it to eliminate the negative 4 in row 3. So that's what I'm going to do. I'm going to write my row operations to describe what I'm doing. So for example, if I want to combine rows 2 and row 1, rows 2 and 1 to eliminate x, I might take negative 3 times row 1, because that would give me a negative 3x here, and add it to row 2. So if I multiply row 2 by negative 3, I do that on both sides. I get negative 3x minus 6y plus 12z equals 9. And I'm going to add row 2, which is 3x plus 7y minus 15z equals negative 12. And you can see that when we add, the x terms add to 0, thus canceling. The y terms give us y. We get minus 3z equals negative 3. And I'll call that row 4. Notice there's no x here. This is going to be one of the equations we have in our system of two equations. Now I need to eliminate x again using two different equations above. So I'm going to use rows 2 and 3 and eliminate x. And to do that, I'm going to take a negative 4 times row 2 and add that to row 3. Sorry, positive 4 times row 2 and add that to row 3, because that'll give me a positive 4x and a negative 4x. 4 times row 2 gives me 4x plus 8y minus 16z equals negative 12. And then just add row 3 to that. And the x's cancel. We get 2y minus z equals positive 4. And we'll call that row 5. So now I've got two equations with the variables y and z. So I can solve that system. And what I'll do to solve that system is I'll just take, let's say I want to eliminate the y. Well, I can take negative 2 times row 4, which will give me a negative 2y, to cancel with the positive 2y in row 5. So I'll just add row 5. So negative 2 row 4 gives me negative 2y positive 6z equals positive 6. And then copy row 5, 2y minus z equals 4, and add those together. The y's cancel. We get 5z equals 10. And now we know that z equals 2. And once we know that z equals 2, we could plug that back into row 4 or 5 to solve for y. So I'm going to plug that back into row 4. Row 4 would be y minus 3 times 2, which is 6, equals negative 3. And now I can add 6 over to see that y equals 3. So I know z and y. Now I need to figure out x. To get x, all I have to do is plug these y and z values back into any of my original equations, and I can solve for x. So let's plug both of those back into row 2. X is what I don't know, so I'll write x plus 2 times y, but y is 3, so 2 times 3 is 6, so x plus 6, minus 4 times z, so that's minus 4 times 2, which is minus 8, equals negative 3. So I have x minus 2 equals negative 3, which means that x equals negative 1. So our solution is the ordered, what we call ordered triple, because there's 3 coordinates. X is negative 1, y is 3, and z is 2. Now, I'll just mention what this means geometrically. If you were to graph these equations, then you'd have to have 3 dimensions because there's 3 variables. And each of these equations represents a plane, a flat surface in 3 dimensions. So this ordered triple, this point, is a point in 3 dimensions, and it happens to be the point where these 3 planes intersect. Okay, so that's the geometric interpretation, is this ordered triple is the point where the 3 planes intersect. Let's do another example. Okay, so in this example, we have 2x minus y plus 4z equals negative 3 as our row 1. X minus 2y minus 10z equals negative 6 as row 2. And 3x plus 4z equals 7 for row 3. Now we want to eliminate a variable so that we get a system of 2 equations with 2 variables. And I can see row 3 doesn't have a y. So I'm going to use row 3 as one of my 2 equations in my system of 2 variables, 2 equations. So I need 2 equations with x and z. And I already have row 3. So what I want to do is eliminate y from row 1 or row 2. Okay, so if I analyze my y's, I've got a negative y and a negative 2y. If I can make the negative y in row 1 into a positive 2y, then it would cancel with the negative 2y in row 2. And to make this negative y into a positive 2y, I need to multiply row 1 by negative 2. So I'm going to take negative 2 times row 1 and add it to row 2. So negative 2 times row 1 gives me negative 4x. Here's my positive 2y that I was trying to create. Minus 8z equals positive 6. Be really careful with signs and multiplication when you do this. Then I'm going to add row 2, x minus 2y minus 10z equals negative 6. When I add my x's, I get negative 3x. The y's cancel. I get minus 18z equals 0. And now I have an xz equation, which is what I wanted to go with row 3, which is also an xz equation. But I do notice that in this equation, everything's divisible by 3. So I might as well divide both sides by 3 to make the number smaller. And in fact, well, you could do that, but actually what I'm noticing now is that I'm wanting to use row 1, and we'll call this row 4. Sorry, we want to use row 3 and row 4 to eliminate one of those 2 variables. And I can see that if I add row 3 to row 4 right now, the positive 3x and the negative 3x will cancel. So I'm simply going to take row 3 plus row 4. So we get 3x plus 4z equals 7. And I'm going to add to that negative 3x minus 18z equals 0. And when we add those, we can see that the x's cancel, and we have negative 14z equals 7. Well, now I've got one variable. I can solve for z by dividing by negative 14, and 7 over negative 14 reduces to negative 1/2. Now I have my z value. So I can plug my z back into row 4 or row 3 to solve for x. So let's go to row 3. So I have 3x plus 4 times z, which is negative 1/2, and 4 times negative 1/2 is negative 2, equals 7. So 3x equals 9, which means that x equals 3. So now we have x and z. Now we need y. Well, to get y, I can plug this x and z back into row 1 or row 2, not row 3 because it doesn't have a y, but row 1 or row 2 to solve for y. So let's plug this x and z combination into row 1. So if I do that, I'm trying to solve for y, so I've got 2 times x, which is 2 times 3, or 6, minus the unknown y, plus 4 times z, which is negative 1/2, so that's minus 2, equals negative 3. So we have negative y plus 4 equals negative 3. Subtract the 4 over to get negative y equals negative 7. Finally, divide by the negative 1 to see that y equals 7. And we have solved for all three variables, and our solution is the ordered triple. X is 3, y is 7, z is negative 1/2. And of course, this is the point in 3 dimensions where these 3 planes intersect. Okay, let's do a third example. Row 1 is y minus 3z equals negative 5. Row 2 is 2x plus 3y minus z equals 7. And row 3 is 4x plus 5y minus 2z equals 10. And I can see I've got row 1, which has the variables y and z. So now I want to try to get another yz equation from rows 2 and 3. So I need to eliminate x. So if I look at the x column of rows 2 and 3, I can see that if I multiply row 2 by negative 2 and add it to row 3, that's going to give me negative 4x plus 4x. So again, I'll take negative 2 times row 2 and add it to row 3. So negative 2 row 2 is negative 4x minus 6y plus 2z equals negative 14. And we'll add that to row 3. The x's cancel, and we get negative y. The z's cancel also, and we get negative 4. So that's interesting. We have one variable here instead of 2, but that's actually a bonus because now we know we can solve this for y by dividing both sides by negative 1. So we know that y is 4. And if we know that y is 4, the smart thing to do here would be to go back to row 1 and plug 4 in for y, and we can solve for z. So I get 4 minus 3z equals negative 5. We'll subtract the 4 over to get negative 9, and we'll divide by negative 3 to get positive 3 for our z value. Well, now we know y and z. We can plug those back into row 2 or 3 to solve for x. Let's plug into row 2. So we have 2x plus 3y, which is 3 times 4 is 12, minus z, which is 3, equals 7. So 2x plus 9 equals 7, which means 2x equals negative 2, and x has to be negative 1. And so our solution is the ordered triple negative 1, 4, 3. Let's do one last example. Row 1 is x minus 2y plus 3z equals 11. Row 2 is 4x plus 2y minus 3z equals 4. And row 3 is 3x plus 3y minus z equals 4. And so we have three variables in each equation. We have to pick a variable to eliminate. And you have lots of options here. You can eliminate x, you can eliminate y, or you can eliminate z. It doesn't matter. You'll come up with the same answer in the end no matter how you choose to do this. Now, I noticed that in rows 1 and 2, if I simply add those together, the y's will eliminate. And I also noticed that if I add rows 1 and 2 together, the z's will eliminate as well. So that's pretty interesting. Let's see what happens if we add rows 1 and 2. I'm not going to write, since I'm just adding the rows as they are, I'm going to do that up here. So I'm going to have x plus 4x, so that's going to give me 5x. The y's will cancel, the z's will cancel, and on the right side I'll have 11 plus 4, which is 15, which means that we can solve for x since there's only one variable. X is 3. Now, we know x, but we still don't know y or z. So you've got some options here. You can plug x back in to all three of these equations if you want, and then you'll have three equations with just y and z, and you can try to solve them like that. Or I'll do it a bit differently, not that it's better or anything, just a different way of looking at it. I know x, I need y and z, so that's kind of a hint that I need two y-z equations. So I need to eliminate x in order to get two y-z equations. Well, I've already used rows 1 and 2, so I don't want to use those again. So let's use row 1 and row 3 to eliminate x. So if I want to eliminate x in rows 2 and 3, I can literally eliminate them by making the 4x and the 3x a positive 12 and a negative 12. Or I could just plug the 3 in like I talked about before, and I can see that, all right, row 2 turns into 4 times 3, which is 12, plus 2y minus 3z equals 4, which is the same thing as, if I subtract my 12 over, it's 2y minus 3z equals negative 8. And then row 3, if I plug 3 in for x, is 9 plus 3y minus z equals 4. And same idea, let me fix my typo, 3y minus z there. Subtract the 9 over, and I get positive 3y minus z equals negative 5. And so x is gone now, and I have a system of two equations with y and z. So let's call this row 4, and let's call this row 5. And I need to eliminate y or z. I'm going to eliminate z, because I've got a 1z here and a 3z there, rather than having to multiply both the equations by something to eliminate y. Let's make the negative z in row 5 into a positive 3. So I'll multiply row 5 by negative 3. So negative 3 row 5. Plus, I'll have a positive 3z here. I just have to add row 4 to cancel with the negative 3z. So negative 3 times row 5 is negative 9y plus 3z equals positive 15, and add row 4, which is positive 2y minus 3z equals negative 8. Adding those together, we get negative 7y, z's cancel, equals positive 7. Divide by negative 7, and we can see that y is negative 1. Well, now we know y and x, we still need z. And what I'm going to do is plug this y value back into row 4 or 5 to solve for z. So I'm going to use row 5. So I've got 3 times y, which is negative 1. 3 times negative 1 is negative 3. Minus z equals negative 5. So I can add my 3 over. So I get negative z equals negative 2. And finally, dividing by -1, I can see that z is 2. So the solution to this system is the order triple 3, -1, 2. And there are 4 thoroughly worked examples of solving systems of 3 linear equations by elimination, basically. I hope it all makes sense, and I hope you do well on your own. Good luck.